Greetings, students. Good to be with you. Today we are going to start our CNC 2 semester, and we're going to be doing quite a few different labs. The first lab that we'll be doing today is going to be called Lab 1, and it is the drill tap bore file, and you'll see it in your DXF files. We will also, after we're done this one, we will do the same exact file in Mastercam. So we'll be doing one in Mastercam, and that's what we're going to do today, and one in Mastercam. So you can expect us to be doing that kind of thing throughout the semester this year. So without any further ado, let's go ahead and get started. So I'm going to open my files, and if you go to your desktop, I'm going to have to go elsewhere, but you go onto your desktop, you'll see these files. So you will see down here, you will see CNC 2 2024, 2025, 2026 students. And if you click on that, you'll see that there is a CNC 2 2025, 2026 students Mastercam and CNC 2 2025, 2026 students Mastercam. So we're going to go to the Mastercam one and open this up, and we're going to go to the 2D DXF file. So these are going to be the data exchange files that you're used to. And we're going to open this up, and we're going to go to DXF drawings, and then milling drawings. And then in there, you're going to have to come down here and change this into all files to be able to pick up all the DXF exchange files. And you will see Lab 1 drill tap bore plate revised drawing. So then you want to open that up in Mastercam. You'll see this system message, just disregard and hit OK. And you will see the file come up. And so that's the one we'll be working on now. And so the first thing we need to do is go into our levels, which I'm already in. And you will see that there's 110 on level 0. 64 in visible ANSI, template 72, 16 in hidden and 16 in narrow. Hidden, narrow, and hidden ANSI, and then border 27, 2, and 9. So all of those things have to be moved to one level, and then we're going to separate them and into two files, basically, or two levels. One will be geometry and one will be dimensions, and that's all we need. You don't need to make a machining file here. So we're going to go ahead, and I'm going to grab this whole thing and draw a box around it and capture everything or group it. And then I'm going to go to home up here, and then I'm going to go to change level. And you'll notice that my check mark, okay, is on level 0. So I'm going to change that name to geometry. And you should do the same now. And we're going to say move, because you want to make sure you say move. If you say copy, it's going to copy right over it. So you want to say move and hit the green check mark for OK. Now you will notice that you have 316 entities under geometry. So at this point, we want to rename this one here, visible ANSI. And what we can do here is bring the check mark up next to it, and then we can go in here and say rename. And so what we'll rename this is dimensions. Okay. And then we will go ahead and capture that. So while we have this check mark here, it's always best to have the check mark or the active level ready to be able to receive the information that you want to give it. So the first thing I'm going to do is I'm going to gather everything on this that has to do with dimensions, the template, everything. So I can go in here and I can draw a box down here and grab a lot of that stuff just by drawing a box. I do not need to hold the control key down as we do with Mastercam. Not so in Mastercam. You can simply just draw a box around the areas you want to capture, and it will capture it. And then I'm going to go in here and I'm going to grab, anything here that needs to be grabbed for dimensional purposes. This will take some time. You'll have to zoom in on it and just make sure you grab everything. Boxes aren't good with this. Your best bet is just to grab them individually. You can try to do it with a box, but it just seems that dimensions just don't seem to like to be captured by a box. Make sure you get all your arrows, get the typicals, grab all of those. All your dimensions down here at the front view, the side view. And then lastly, you'll want to capture the 3D view because you're not going to be needing that for machining purposes. So you'll have to play with this a little bit, grab some things. You can draw a box around some things here and it'll help, but doesn't always capture everything. So you'll have to just carefully take a look at what you've grabbed. Once you get everything done here, then we're going to go up here again to Home, and we're going to go to the same change level, and you'll notice that it has the dimension level already up here because we have our green check mark here. So we're going to say Move again, and we're going to say OK down here, and then when we click off of this, if we bring our check mark, we just bring your check mark by double clicking up here and then use the level visibility and click on it to make sure that you captured everything. If you didn't, then go back and recapture whatever you might have missed. Okay, so at this point then we have everything pretty much ready here. We have it divided into 2 levels. However, we have a lot of levels here that are unnecessary. So what we can do here is hold your control key down and just keep grabbing these till you grab them all. And then you can right click and come down here where it says Delete, and then slide over to Selected Level, not Empty Levels, Selected Levels. And click on that and they all disappear. Then you can come up here and bring your level visibility back, because now we want to grab our lower left-hand corner and create a Cartesian coordinate right there in Mastercam. All right, so the next thing we do to get that, we will grab this whole thing here and we will come up here to Transform and we will say Move to Origin. And it's going to say Select the point to translation from, and that is going to be this lower left-hand corner. Left click on that and you'll see that everything disappears. Don't despair. Right click and say Fit, and everything will come back. Now the color, you may not like this color, so if you want to change that, you can simply right click up here and come over here to where it says Clear Colors, and it will bring it back to white. If you don't mind the color, you can leave it as it is. That's fine. And now I want to make sure I save this. So I'm going to say File, and I'm going to say Save As. And it's going to go back to the files that I was already at. And I'm going to put in here Revised Machine, and then underscore and class. And hit Save. So now if I hit Open here, you'll see that that file will appear here. It says Lab 1 Drill Tap Bore Revised Machine Class. Okay, so that's what you should have. So now what you're seeing here is that the DXF file is listed above it, and right below it is the work that you're going to be doing on this lab. So we can cancel that out and we can now begin to do our work. So we don't really need all of the dimensions and all of that stuff right now, so we can get rid of all of that and keep only the stuff we're going to be working on. And the first thing I want to do is make sure that I tell Mastercam what kind of an operation I am doing. At this point, Mastercam does not know what operation we're doing. So we need to click on Machine up here. and we need to select what kind of work we're going to be doing. So I'm going to come over here to Mill, and I'm going to click on Mill, and I'm going to pick up Default. That's the default post-processor that Mastercam offers for what we're going to be doing here. And if we go, now we need to go to Tool Paths down here, or wherever yours is. Sometimes they're up here. If you're having a problem finding them, if you look at View, you will see Recent Functions, Levels, Tool Paths, and if these are not blue in color, they haven't become active, and so you'll have to click them to become active. But at this point, I have Recent Functions, I have Levels, I have Tool Paths, Solids, and Planes. So that's really what I should have down here at the bottom or up here along the side, wherever yours might be located. So now we look at our, we have a Machine Group 1 here, and if I close that or click the minus sign, it disappears. If I re-click it, it appears, and then this plus sign here will give me the ladder of things that we need to do with this part. All right, the first thing we're going to go to is the machine itself. And you're going to lose the drawing for a moment here. But you go in here and take a look and make sure that it says Mill Default. And the control here is Default MCAM Control. And the post is C Users MP FAN PST Post. So that's all good, and that's when you click on default, or when you click on machine and default up here, it's all going to be here. You're going to see that. You can reconfigure it, but there's no need to do that at this point. So we're going to move on down here and see what else is active. So we have operations and comments is made active here. Preview settings is set to housing, and those things are default, so you should not change them. But you're going to want to put your program number down here, so I'm going to put 100 in here. And I'm going to say the sequence numbers of the operations should start at 10, and then increments of 10 after that. And that's all we need to fill out there. So now we can go to the next one, which is Master Model. And there really isn't anything in Master Model to do. It says material is aluminum, but this is not really, doesn't change anything. So I'm just going to leave that alone. I'm going to go to the stock setup next, which is the most important part, is getting your stock set up for all the machining operations. So the second entry here is called Create Rectangle Stock. And it's asking for me to select this, but I must go down here first and take a look at what I have in this column here. I want to make sure that I have all the stuff that I need here, like the push-pull, for instance, but I guess it's asking me to do the selection first, so I'll do that. I'll start here and go there, go there, and go there, and I will say end selection. And then I'm going to put this into isometric. And now it's ready to receive the stuff I want. So the length is 8, the width is 2, and the height is 0 at this point because we have not created a solid yet for our simulation. So then we need to come down here and make sure that we have push-pull activated, and incremental is very important on this. Once we do the size, like I'm going to add 31 thousandths to each side of this 8 inches distance. So I'll add 0.0312 there, 0.03212 there, and there. That will give me a 30-second per side all the way around this part, and then I'll deal with the top afterwards. So in this way, we have to go with both directions. So we click on both directions, and it's going to be incremental. If you don't have incremental and you have absolute, it's going to put it all on one side. So you want to make sure this is incremental and that you have the check mark both directions. And then you can come in here and you can start to change this. You will see that we have 8, 2, and 0. So with the 8, I'm going to put 8.0312, okay? And for the 2, I'm going to put 2.031.2. And then for the height, since we're going to put this in a vise, and this is going to be different than the example you did in CNC 1, this time we're going to make this for real. It's going to be like put in a vise. We're going to insert it in the vise at least 1/4 of an inch, and then we're going to machine this on the top, get everything done, periphery and everything, and then we'll go ahead and flip this over and machine the other side to height. So that being bared in mind, I'm going to go for my height 1.250. And then I can click out here in space, and you'll see that my 1.250 appears. But notice it gets dropped from the top 0 down, 1.250. If I want to add something to the top, I need to come over here where these XYZ arrows are. I need to click on this, right? And then I need to click on it a second time and make sure I have this active so I can put in the value. I'm going to put, oh, by the way, I need to go down here and say not both directions, okay? So let's go ahead and do this again. I'm going to exit out of that because that will try to put it on both sides. So I'll go into stock setup again. All right, go back in here again, and we'll activate this as we did before. And selection, put it into isometric, put the push-pull, make the push-pull active for incremental both directions. And we're going to put in here again 8.031.2 and 2.031.2. And the height will be 1.25. And then we can click out here. And if we look at the top view here, we should see extra material out here. And you can see that right here. You have 31 thousandths here. You have 31 thousandths here, 31 thousandths there, and 31 thousandths here. So that worked out well. Now all we have to do is go to the height of the top of the piece. So I'm going to shut off the both directions, and then I'm going to come in here and grab this again and put in the value that I want. So that's going to be 0.031.2, and I hit enter twice, 2 times. So you notice down here now the height is 1.281.2. It added the 031.2 to the top. If we turn this to the front view, you will see now that you have this 031.2 at the top, okay? All right, so that gets our stock values where they should be, and there really isn't anything else here that we have to fill out except for to go to the next one, which is work holding, and we're not going to put in a vise, so we don't need to go there, and we're going to do our tools later. So we don't need to fill these out at all, these last 3. I just want to hit the green check mark, which says OK. And you say, well, it disappeared on me again. We can fix that by going into toolpaths here. Click on toolpaths, stock display and stock shading, and then go to isometric, and you'll see your part. Previously, Mastercam didn't make you do that. When you clicked on OK, after you filled out all the information, it would show just like this. I don't know why they changed that, but again, they make it hard to find things from time to time. Same with the Mastercam, no different. These companies just don't like user-friendly things, I guess. But that's my pet peeve for the moment. At any rate, we're here now. We have everything we need here. We have our material, and we have our stock values in there, so we're ready to do the machining operations themselves. All right, so we're going to get started with face milling, but we need to go up to the tool manager and we need to start making some tools. So you've been through this before. You know that you have to go into tool filter and say none here so that everything is unactive. And then you want to pick the tool that you want to use. And I'm going to pick the face mill, right? And I'm going to hit the green check mark and notice that all the face mills then come up. And we want a 2-inch face mill, so I'm going to grab that and I'm going to left click and hold it down and drag this up and release it. Okay. Now I'm not going to do anything with it yet. We have to go back in there and change some values. You will have to do that with a SpreeCam as well as with Mastercam. You've got to make sure, like for instance, your tool number up here is 322. Now this happens to be, is going to be tool number 1, okay, in our list of tools. So obviously 322 is not going to work. We have to change that later. So I'll hit the tool filter again, and this time I'm going to say none again, and I'm going to pick up a center drill. I'm going to pick the center drill and say OK, and then I'm going to look at the center drill options here. Notice number 1 center drill, or the number 1 tool they have listed, is a 0 center drill, which is not what you want. You want a number 3, and that is tool list number 8, but it's still a number 3 center drill. And you grab this and bring this up. That's going to be your for all drilling all the holes. And again, we'll come back later to modify that. Then we want to get a drill, okay, to do the drilling operations. So I'm going to say, again, none, and I'm going to grab the drill file here and say OK. And then I'm going to be looking for a 257 drill. Which is a letter F. We're going to drag this up here and put it in place. Now notice it moved it out of order, but don't be concerned about that, because when we start changing the values, like I'll give the face mill tool number 1. And when I do that, it's going to put it at the top. When I put the center drill as number 2, it'll put me in line for number 2 and 3 and so on. So we'll fix that later, so don't be concerned about that. All right, the next in the tool filter I want to go to is the tap. So I'm going to say none here, and I'm going to look for right hand tap. There is a left hand here. Make sure you pick right hand. All right, and hit OK. And we're going to be looking for a 5/16 18. And if you're not quite sure about that, you can always go down into the levels. Well, I guess we can't go into the levels right now, but just have to take my word for it. We're going to use a 5/16 18 tap. Let me just make sure that's correct. Yep, 257 drill, okay. So I'm going to look for a 5/16 18 tap. All right, here's 5/16 18 right here. I'm going to drag that up here and drop that off. And after we're done the drilling, the center drilling and tapping, we're going to be needing to have a 1/2 inch end mill. In fact, we'll need the 1/2 inch end mill before we even do the holes. We're going to end up doing a face milling operation first. Then we're going to machine the periphery of the part, okay, take that 32nd off the walls. And at that point then we will begin to do our machining of the bores, okay, and then the drilling and the tapping will probably end up last. But nevertheless, I'm still putting it in this order. So 5/16 18 is the next thing I want to drag up here. Looks like we put it in here twice, so I will delete this. All right, 5/16 18, and then the last tool that I'm going to be needing is going to be the 1/2 inch end mill. So I'm going to say none here, and I'm going to look for the flat end mill right here and say okay. And then I'm going to be looking for a 1/2 inch. And here's a 1/2 inch, all right? And I'll drag this up here and put that in place. All right, so at this point now we can go ahead and we can begin to change these, correct the things that are wrong. So I'm going to start out with my face mill, and I'm going to double click on it, and you'll notice that that tool comes up. This was never the case before with the 2024 version of Mastercam in 2025. I don't think he even had it then. We used to be able to create the tools without having this come up like this. So this is kind of some new options here, if you will, and they're already giving you some dimensions here that are going to be pertinent. Okay, it's a 2-inch cutting diameter. Secondary is 2.492. Overall length 2.1. Cutting length 1.575. That is what they come up with when they measured these tools at Mastercam. The angle here is important. If you're using a tool with a 45-degree angle with an insert with 45 degrees down here, you need to put that in here. The shoulder length, of course, is going to be the length of the head itself, and then the upper diameter is what fits into the holder itself that goes into the machine, which is a 40 cat taper. All right, so that's 3/4, and that's pretty much standard. If we go to the first one up here where it says tool, you'll notice the tool number here is 322. So make sure it's 1. And then when you change that, it'll make them all 1. This should be US units, okay? And there's no helix angle on this. And that's pretty much all you need to do here at this category. We've already been here. Let's go to the last category. We will not do anything with coolant. That's later. So with the parameters section, this is where we put in our speeds and feeds. So I'm going to go down here to spindle speed first and put 2,000 in here. So you'll want to enter that in. Retract means that after you're done making a face mill operation, the speed of the tool getting up out of there, out of the way. So I'm going to put 50 in there for that. And then for the plunge rate, that should be, somewhat less than the feed rate. So I'm going to make this 18. And I'm going to make my actual feed rate in X and Y at, I'm going to say 20 inches a minute. Number of flutes here is going to be 4. And all of this down here is not necessary. The fact that you are using this for a rough and finish, these two need to be checked off. Now that's usually it is already, but just double check. And once you're done with that, you hit OK. And then you see the holder that they give you, which is a generic holder. We will change that too as we progress through this. And then you hit the check mark one more time, and that is done. Now you see that the face mill now is not 322, it's actually tool number 1. Now the next one is going to be the center drill, so I'm going to go ahead and double click on that. And your center drill will come up. And down here there's a list of categories here for center drills. So if we scroll down here, we come to a number 3, and I get this changing the standard size, overwrites the geometry. Settings, do you wish to continue? Yes, I do. It already has the dimensions already in here, if you notice though. For instance, you have the 1/4 inch here, and as we go down here, you see that the shank diameter is already a 1/4, just like it says here. And you'll see that the overall length is 2. So basically, that information gets transferred down here. Then the tool diameter at the bottom is 109, and the length is 142, and the angle is 118 degrees. And then, of course, the chamfer itself is 60 up here. So that's all good, and we don't need to do anything more there. We do need to put some feeds and speeds. Oh, and we have to go up here to the first one and make sure that this is not tool 8, but actually tool 2. And that changes it all to 2. And we've already done that. Now we can go down to speeds and feeds. It is not a carbide. It's high-speed steel, so you'll need to change that. Make sure the spindle direction is clockwise. And now we'll put in our spindle speed. Our spindle speed here is going to be 2,000. And our retract is good there. Plunge rate is 18. And our feed will be 20. This down here will not need to be filled out. You'll notice that it changes everything when you click up here. It is 2 flutes, and we're going to say OK. It gives you a generic holder here, which we don't really have to deal with right now. And the length is a little bit long. We can also fix that later. So we're going to give this an OK here, and now tool number 2 becomes the number 3 center drill. All right. The next one we want is going to be the F drill. So we will go in here and do the same thing we did before. This is going to be tool number 3. So I'm going to put 3 in here. And it will bring 3 up for the rest of those. We need to search out here a number 3 center, a 257 drill. So we can look over here at the diameter column and we can scroll down here. Until we come to 257. And we have to be careful what we select here. They're giving you at least 3 entries, 4 entries here. They have a heavy-duty screw machine. They have heavy-duty taper. We don't have any of that. Screw machine, we don't have a screw machine. F-taper, we don't have that. So we just keep on coming down until we get to the jobber's length. And again, that thing is going to come back up. Just say yes. And then we can come down here at the bottom and we can start to enter in our values. 257 is good there. It doesn't need to be 4 inches long. I'm going to make it 3.0. The cutting length on that is going to be, the generic is 2.875. I'm going to put in here 2.75, okay, and the 118 degrees is good there, and the shoulder length is there, and that's good. 257 for the body of the drill, and so that looks pretty good. So we'll leave that alone there, and we're going to say, let's go to the next one. So now we're going to change our speeds and feeds. 5,945 is very fast for a drill. This is cold roll steel. I would say your better bet here is 1200. And this can be 50 for your retract. 50 point. Plunge rate, 18 point. And your actual feed rate should be somewhere around 20. It's high-speed steel. We want to go clockwise. We can click up here to make sure that everything changes up here. And we say good. And now we're ready to close this one out. So that's number 3. The next thing we want to do is go to our tap. So we're going to grab this tap here and double click on it. And we're going to start out with the tool itself. So it's not going to be tool number 221. It's going to be tool 4, I believe. So I'm going to say no here for a minute. And just make sure that it's tool number 1. Yes, it's tool number 4. So we'll double click on this, get this back up. And I'm going to put in 4 here. And that looks good there, US. Right hand tap, make sure it says right hand here. And then we'll look in here in the files to find ourselves the 5/16 18. 5/16 unified course. And we'll go down here now and check the diameters and lengths. 18 threads per inch. Okay. The cutting length, they have it at 1.125. I think it's just going to be a little bit more than that, so I'm going to say 1.25 for that. Shank diameter is 318. That should be 312. Oh, we don't have to worry about that. We'll just leave it alone. And the overall length, they're giving it at 2.7. All right, so it's not going to be a plug. It's not going to be a bottoming tap, rather. It's going to be a plug tap. So many times you have to come down here and make sure you select the right one. If you're using a bottoming tap, it's going to be flat at the bottom down here. Like if I change this to bottoming, you see how it turns flat? This is going to be a spiral point plug, so it's going to have a taper in the end. And so everything else looks okay here. So we're going to say, oh, we're going to go to this next one and get our speeds and feeds in here. I'm going to go with 400. You don't want to go fast with a tap. So you, especially since we're tapping, we're rigid tapping, we want to put that in first so that it can calculate what we need here. The next thing is a retract, and I'm going to say the retract is going to be 50 again. I'm going to say that the plunge rate is going to be 18 again. And then up here, you'll notice that it says 22.22222. Now in class we said that if you know what the pitch of the thread is, so if you take 1 divided by 18 with your calculator, the pitch is 0.055555, just as it says right up here, okay? And now you multiply that times the 400, and you're going to get 22.222. Now, a lot of you students have put in values in here that don't belong here. It calculates itself. If you tell it what the amount of the the threads are, or you put the pitch in here, whichever the case may be, and it'll do the calculation of the feed rate for you. But if you go in here and override this, it's going to give you what you asked for. And a few of your students have put in the wrong values for tapping in last semester. So I think it's very important that you make sure that you let Mastercam put in the value of the feed rate once you've given it the spindle speed, and it knows that it's a 5/16 tap. It knows that because back here, right, we went in here and put in 5/16, right? So now it takes that and says, okay, well, this tap is going to have 18 threads per inch. That ends up being 0.05556. So you should not be tampering with this at all. Just simply put in your speed, put in your retract and your plunge, and it will calculate this by itself. All right, so that's basically our last category, except we don't want carbide. This is going to be a high-speed steel tap, and we do want to make sure it's going clockwise. So we can hit the OK here now, and hit OK again, and we've got that one. So our last one then is the 1/2-inch flat end mill. So let's go in here and let's double click on this. And we will start out putting in our tool number 5, 5 and 5. And we will move to the next one, the geometry itself. Make sure that you have this one, no corner. Make sure you activate that. Cutting diameter is 1/2 inch. 3-inch overall length. Cutting length 1 inch. Well, you know that our part is 1 1/4 inch thick minimum, because it's putting in at the 1/4 inch of an inch of it is in the vise. So this is going to have to be a lot more than this. So this is going to have to be like 1.75, the cutting length itself. Now it looks a little bit better. This is going to be in your shank holder, and that looks pretty good. Again, make sure that it is a straight type of tap or type of end mill, not tapered in any way. and everything else looks okay here. So then we can go ahead then to our parameters, and we can begin to fill this out. So I'm going to go with 800 here for our speed. Retract, I'm going to go at 50. Plunge rate is going to be 18. And our speed is going to be 20. Now this will change up here. It's a 4 flute. Okay. So everything looks pretty good. Percent step over, they have 50 here. I don't do anything here. I try to make sure I do that when I fill out my technology page. And then I'm going to say OK with that. And I'm going to say OK again. All right, so we've got all the tools here identified except for the thread milling operation. So what we will do in my next session, we will deal with that first, and then we'll go ahead and go through the machining operations for this part. So have a good afternoon, a good day, and I'll talk to you soon.